Okay, so I'm going to show you a strategy of how to calculate volume when we're working with the cubes, okay? So that you can support your mathematical claim and also bring in what we know about volume to say this cube belongs or this cube doesn't belong, okay? So I'm going to start with this cube right here, this rectangular prism made of cubes, okay? I know that when I'm thinking about volume, I'm wondering how much fits inside a rectangular prism or how much the rectangular prism, how much space it takes up, okay? So this rectangular prism, what's going to help me are the length, the width, and the height. So the length of this rectangular prism is 6 cubes. The height is 2 cubes. And the width is 2 cubes, okay? If I see a picture like we've seen with the what doesn't belong, sometimes it's really hard to think about what the volume is if you try to count each cube, because with a picture, you can't turn it and break it apart and manipulate it. And so you might actually miss some of the cubes, so you might not get an accurate answer for your volume, okay? Another strategy that we can use, though, is we can take and count each cube, but we can also multiply the height, the width, and the length to find the volume, okay? And that's what I'm going to show you today. If you feel like you already have a strategy to calculate volume, you don't need to watch this video. However, if you want to see 2 different strategies to support that is going to help you then turn around and support your what doesn't belong argument, keep watching this video, okay? So I'm going to show you 2 different strategies today. Okay, so how I started was I just started by labeling the length of my rectangular prism, the height, and the width. And I just labeled it once. I didn't label the length. I didn't label it 4 different times. I just labeled it once because I want to know what number I need to focus in on as a mathematician, and seeing it twice sometimes gets me confused, okay? So I just labeled it once, okay? So with the cubes are a great visual when I'm working with volume, just like you guys know in class, because I can break it up. Okay, so I have 6, 12, 18, 6, 12, 18, and then I have 24. Okay, so I have 24 cubes total. So that would represent the volume. Okay, and then so whatever my unit is, cubed. Okay, I'm not worried right now about the unit, but I do know whatever unit I'm measuring in that I want to make sure that it's cubed. Okay, another strategy that we can use, and a lot of you guys were using last week, is to multiply the length, the height, and the width. Okay, again, on my model, I've only labeled each dimension once that I'm focusing on. Okay, so I took 6 times 2 times 2. First, I did 6 times 2 equals 12. So I just did these 6 times 2 first. And then I had to do 12 times 2, and that got me 24. And if I wanted to check that, I know that's the same as 12 plus 12 equals 24. Okay, so this is 24, and then my unit cubed, okay? Which right now my unit is just like the cubes or the blocks that you saw in the video, okay? So I'm just kind of working with those materials. If I was actually measuring a rectangular prism like around my house, then I would say like inches cubed or centimeters cubed, but since we're just kind of looking at the images and the models, then I'm just going to leave that one blank, okay? But I know that if I was measuring volume, that it would be cubed, okay?